So today we are working on solving systems of equations by using the substitution method. Okay, and so systems of equations just means that you have two or more equations to solve and that you want to make sure that your answers work in both equations. So you're going to have more than one variable, just like you have more than one equation. Okay, so I'll start with just a quick example. Okay, so y equals 2x plus 5, and we have x plus y equals -4. So our goal is to find an x and a y that work in each of these equations. Okay, so what's nice about this is that we have already, or this is already solved for one variable, right? We already have a y equals something. Okay, so we have y equals 2x plus 5, right? So we're going to take that y and substitute 2x plus 5 into your other equation. So we're going to have a new equation that says x plus 2x plus 5, right? What we have our other y as equals -4. Okay, so now we're just going to use our algebra skills, right? So we want to simplify on the left side as much as we can. So we can say, okay, well, x plus 2x is equal to 3x. Hold on, sorry, I'm jumping ahead of myself. Okay, so x plus 2x, right? Those are like terms. So we have 3x plus 5 equals -4. Right? And we can't simplify any more on the left-hand side of our equal sign, right? Because these are not like terms. This has an x variable in this term, 3x, and this is just a constant, the number 5, right? So we can't combine those. So we want to get our x all by itself on this left-hand side. So we're going to subtract 5 on both sides, right? Because I want to get rid of the 5 over here. But what I do to one side of my equal sign, I have to always do to the other, right? So now we have -4 minus 5, and that's going to be -9. So I have 3x equals -9. Again, I want this x all by itself, so I'm going to divide by 3, right? That's the inverse of multiplication is division, right? So 3 times x, to get rid of that 3, we want to divide by 3. 3 divided by 3 is 1, so we're just left with x equals -9 divided by a positive 3 is going to give me a -3. So now we have that x equals -3, right? So you want to take that and use that in your other equation. So we had, remember, we have y equals 2x plus 5. Okay, so we're going to replace our x now, or substitute our x with what we found out here, right? X equals -3. So we have y equals 2 times -3 plus 5. And now we're just, again, using our math skills. So 2 times -3 is -6 plus 5. So we get that y equals -6 plus 5 is going to give me a -1. Okay, so now we have x equals -3 and y equals -1. And so we want to take these guys and we want to check our answer and make sure that we are correct, that it works in both equations. Okay, so we want to check x equals -3 and y equals -1. So we use each equation. Okay, so y equals 2x plus 5. Okay, I'm going to get out of this red because I'm not a fan of it. And so we just replace y and x. So we get -1 is equal to 2 times -3 plus 5. We just want to make sure that that's true. -1, does that equal 2 times -3 is -6 plus 5. So -1 equals -1. Check. Okay, and now we're going to use the other equation that we have. X plus y equals -4, right? And again, we're just going to put in -3 plus -1, what our answers, right, equals -4. Does that work? Well, yeah, -3 plus -1 is equal to -4. So check, yes. Okay, so you can see, right? This is just our substitution method, right? So the first step in your substitution method is that if you don't have a nice y equals or x equals, is that you want to solve it in terms of y equals, right? We want to always have one variable equal to something on the right, okay? So that we can replace it. And I'll show you this next example is going to be one where you have to do that extra step where it's not just y equals or x equals something, okay? So this we have 3x plus 5y equals 25. Okay, and our other equation is x minus 2y equals -10. Okay, and you can see here that even though the coefficient, right, the number in front of your x variable here is 1, we still have not solved for x, right? So what you want to do is take this equation and solve for x. So x minus 2y equals -10. We're going to add 2y on both sides, okay? And so we get x equals -10 plus 2y, all right? So now we've solved for x. We're going to replace that into our other equation, right? We're going to substitute what we have for x into our other equation. So we have 3x plus 5y equals 25. Right? So what is our x? X is -10 plus 2y. So we have 3 times -10 plus 2y plus 5y equals 25. Okay. Now this one's a little more difficult than the other one. We have to distribute our 3, right? This is 3 times each term in here. So 3 times -10 is -30 plus 3 times 2y is 6y plus 5y equals 25. So we have -30, and again, we combine like terms. 6y plus 5y we can combine. 6y plus 5y is 11y equals 25. Okay, add 30 on both sides. And we get that 11y equals 55. All right, so I'm going to go up here. 11y equals 55. We divide by 11 on both sides. And so we get that y equals 5. Okay, we are not done, right? That's what our y equals. We still need to find out what x equals. So this is our y. Now we want to find out our x. So again, we're going to take that y and put it into this equation. X minus 2y equals -10, right? So we have x minus 2 times 5 equals -10. X, 2 times 5 is 10. So x minus 10 equals -10. We add 10 on both sides, right? And so we get x equals 0. So that's our answers. Now we have to check, right? We want to make sure that those work in both equations. Okay, so we're going to check that x equals 0 and y equals 5 works in both of those. So 3x plus 5y equals 25. 3 times 0 plus 5 times 5. Does that equal 25? Well, yeah, 3 times 0 is 0, plus 5 times 5 is 25. Yes, that one works. Now we have to check our other one. So we have x minus 2y equals -10, right? And our x was 0 minus 2 times 5. Does that equal -10? Well, 0 goes away, right? So, and it's -2 times +5 is going to give us a -10. So -10 equals -10. So our answer of x equals 0 and y equals 5 worked in both of our equations. So we are correct. And so that's two examples of how to solve a system of equations. I can do some more. I'm just going to stop this sharing, and then I will do some more on another one.